Hi, let's start with the concept capsules. The topic that we are going to look at today is the binomial option pricing method. Now, this is a topic that you're going to see as part of both your CFA as well as your FRM curriculum. And it's one of the two methods that you need to know for calculating the value of an option. The second one being the Black-Scholes model. Now, let's see how do we proceed with the binomial method. Now, the binomial method assumes that the underlying price is limited to only two states in any given interval of time. And that's the reason why we're using the term binomial, because we're talking about only two states being possible at any node. So what we do is we start with the current stock price. Then we take two different states of nature, up state and the down state. So S0 is the current stock price. With probability P, it could go up to SU, U denoting the up state. So the stock price in the up state. And then with probability 1 minus P, it could go to SD, which is the stock price in the down state. When you go to SU at this particular node, again, it could go either up or down. The probabilities remain the same across the tree. So whatever probability we have taken here, P and 1 minus P. So let's say if it's 60% up, 40% down, then that is going to remain the same throughout the entire tree. Then from this point onwards, again, with probability P, you can go up. So SU, here you see square because it's going up and up. And then here you see SUD and SDU. That means either we can take this route that we go up and we go down, or we go down and we go up, but we reach the same point. That's why these 2 points are the same. So all of these are showing you the stock prices in the next state that is possible. Now, in this particular concept capsule, we are focusing only on the 1 period method. So we are only talking about, going 1 period ahead. We are not going anything higher than that. So we will be limiting ourselves to only this part of the binomial tree. So what we need to do for the binomial method is that we first determine what are the two different stock prices that are possible. When we have determined that, then we calculate the payoff of the option on both the nodes, and that helps us in getting an expected value in that time period. Now, once we have an expected value, at this particular time period, we simply apply the DCF formula. So we need to get it back to time period 0. We need to discount it back to time period 0. But remember, in this case, the expected value of the one that you've calculated, you will need to use the probabilities. In a usual DCF formula, we don't use the probabilities because we are assuming that in one particular state of nature or in one particular time period, you have a 100% probability of getting that cash flow. So usually in DCF, we don't use the probabilities, but in this case, we are going to do it. But otherwise, calculation is pretty much similar to how we work with any timeline or the discounted cash flow method. So let's see how to go about doing it. Now, we'll start with a call option binomial tree. So what we will do is, after determining the various stock prices, we will determine the call option payoff in that state. What is the formula for call option payoff? That is max of 0 ST minus K. K is being used for strike price. You can use X as well for exercise price. Exercise price, strike price are both the same things. So whichever notation you want, whether you want to use K or you want to use X, completely up to you. So we'll calculate the option payoffs at all the different nodes, and then based on that, we'll calculate the expected value and then discount it. Now, before we proceed to this, we will need to know a few formulas and a few notations. So let's have a look at that. Now, these are the steps that we are going to follow. First will be, we determine the size and the probabilities of the up move and the down move. We will denote this using U and D, and we'll just see the notations as well. That's going to be the first step, that we determine U and D. Once we have done this, the next thing to do is that we will draw the binomial tree and calculate the payoff at all the nodes. So once you've determined U and D and the probabilities of the price going up and the price going down, that's when we start drawing the binomial tree and then calculate the payoff at the nodes. Once you have the payoffs, we multiply these with the respective probabilities and then calculate the expected value of the option for the entire period. After this step, we'll simply discount this expected value to time period 0, and that gives us the value of the option today at time period 0. Now let's look at the notations and formulas. We will be using pi u for the risk neutral probability of an up move, pi d for the risk neutral probability of a down move. As you would be knowing, pi u and pi d, they have to be complementary. That means that they will always sum up to 100%. So if the probability of an up move is 60%, automatically the probability of the down move has to be 40%. They will always sum up to 100%. Rf is your risk-free rate. U and D are the sizes of up move and down move. Now, there is a relationship between the up move and the down move factors. These are essentially reciprocals of each other. So if you've been given the size of an up move, then D is simply the reciprocal of U. And to calculate this, you can simply use the 1 by x function on your BA2 plus calculator, right? So it's going to help you do it in one shot. So D is equal to 1 by U. Now, what do we really mean by the up move and the down move factor? Let's take a quick example. Let's say if the stock has a probability of moving up by 25%, what is going to be the size of size of the up move? That will be 1 plus 25%. So essentially 1.25. So U will be 1.25 and D, we have just seen, is the reciprocal of U. So in this case, that will be 1 divided by 1.25, which is 0.8. So that is your up move and the down move factor. How are we going to use the up move and the down move factor? Let's say if your current stock price is 30, then how will we find out what are the two prices possible in the next state? That's where we use the up move and the down move factor. Up move will be 30 into 1.25, whereas down move will be 30 into 0.8. So that's how we are going to use it. Now we know how to calculate D now. So U and D is something that we've done. Now the next thing to do is to calculate the probabilities. So we need the formulas for those as well. Now the formula for calculating the probability of an up move is 1 plus Rf minus D upon U minus D. Remember, we are limiting ourselves to the discrete versions of the formula. There is a continuous version as well, but we are focusing completely on the discrete version right now. So 1 plus Rf minus D divided by U minus D. Rf is your risk-free rate. D and U is something that we've already calculated. So in order to calculate the probabilities, the first thing that you will need are U and D. So you cannot proceed to probabilities directly. Keep that in mind. So that is your sequence. First, you need to have the U and D. After that, you calculate the probabilities of up move and the down move. Once you've calculated the up move probability, down move is simply 1 minus the up move probability. So that's not a tough thing to do. So as soon as you start with the question, this is the first thing that you need to do. You need to make sure you have calculated all of this. Once you have all of this, only then can we proceed to drawing the actual binomial tree. Now let's try out a question. So we'll draw the binomial tree for a call option, and we'll use this tree to calculate the value of a call option. Now the current price of a stock is $80. Size of up move has been given to us, and that is 1.4. Risk-free rate is 6%. Strike price is also $80. Remember, we are talking about a call option right now. We will do the valuation of put option as well later. So the strike price of the call option is $80 and expiry is 1 year. Using a binomial tree, determine the current value of the option. Now, what are the steps that we need to follow? We have been given U, which is 1.4. So next thing to calculate is the D, which should be reciprocal of 1.4. So 1 divided by 1.4 will be your D. And once you've calculated that, you need to calculate the probability of up move and the probability of down move using the formulas that we just saw. So this is what we will do. Size of down move is 1 by U, which is 1 divided by 1.4. That gives us 0.714. Probability of up move is 1 plus Rf minus D upon U minus D. Rf is 6%, so that is 1 plus 0.06 minus 0.74, that is the D that we just calculated. divided by the difference between U and D. That is 1.4 minus 0.7. So 0.50 is the probability of up move. What would be the probability of down move? That will be 1 minus this, so that is 0.495. So the probabilities are almost 50-50 of an up move and a down move. Now that we have all the information that we require to build the probability tree, we'll start with the actual diagrammatic representation of that. And I strongly recommend that whenever you're working with the binomial option pricing, do not try to do this without creating the tree. It's going to take you probably a minute or two to create this tree with enough practice, but it's going to help you avoid a lot of confusion in the exam. So don't try to do this using an equation straight away. Make the tree, spend 1 minute or 1.5 minutes extra on that, and it's just going to help you. You won't need to correct anything. You won't need to go back to the question and check. You simply need to rely on your tree. All right, now how do we make the tree? The current price is 80. So keep in mind, the current price as well as the strike price is the same. That is $80. So we start with $80. Then we account for the up move and the down move. The up move is 1.4, down move is 0.7. So what are the two prices and how do we calculate it? We take 80 and multiply that with 1.4. That gives us 112. So that is the stock price in the up state. Similarly, 80 into 0.71 gives us the stock price in the down state. Now, one common error that happens is that people start calculating the expected values here itself. And that's a very, very common error. I've seen that error so many number of times. You have to be very careful about this. Remember, what we've calculated right now is not the option payoff. That's just the stock price. So these are the two potential stock prices which could be there in the next state. We have not even talked about the call option yet. So make sure you don't do that mistake. Remember, this is only first step of the binomial tree. Now here, we know the probabilities, that is 0.504 and 0.4958. The next thing to do is, remember, do not calculate the expected value yet. We have to wait for it. The next thing that we need to do is to calculate the payoff of the call option in both of these states. So what are the values that we have? We have 112 and 56.8. Now what is the formula for the payoff of the call option? That's max of 0 ST minus K. K is 80. We already know that. That's been given to us in the question. However, ST is depends upon which state occurs. So in the up state it was 112 and in the down state it was 56. So we calculate the payoff of the option in both the states. So in the up state, the payoff comes to 112 minus 80, and in the down state, it's 56.8 minus 80 when we do ST minus K. Now remember, we have a max condition. It's not just ST minus K. So max of 0 and 112 minus 80. So 112 minus 80 is positive. So clearly, we have a positive payoff, 32. In the down state, you have 0 and 56.8 minus 80, and that is a negative. What that means is we're not going to exercise the option because it's not beneficial for us. We will be able to buy this stock at 56.8 from the market. So why should we exercise the option and purchase it at 80? So we'll just leave it like that and we'll walk away from that position. We won't exercise it. So the payoff comes out to be 0. Now these are the two payoffs that are possible. What we need to do now is to calculate the expected value of the payoff. We need to combine these two payoffs into one essentially. How do we do that? We take this 32 and multiply with the probability of an up move. We take the 0, multiply it with 1 minus p, the probability of the down move, and we add both of these payoffs to get the expected payoff. So we simply multiply these numbers with the respective probabilities and add them up. This is what we get. So 32 into 0.5041 plus 0 into 0.4958, which was the probability of the down move. So the expected value comes to 16.13. Again, the other mistake that people make, this is not the end of the question because remember, this is the expected value after 1 year. We are not purchasing the option after 1 year. We are going to purchase it right now. So we need to value it at time period 0. So do not forget to discount this, just like any DCF question. This is the expected value after 1 year. So how do we calculate the value? At this point, we simply discount it. Our discounting rate is 6%. So we simply discount this at the rate of 6% for 1 year. So 16.13 divided by 1.06, that gives you 15.21, and that is the value of the call option. So these are the steps that we followed. We need to have U, D, the probability of up move and the probability of down move. As soon as we have that, we move on to creating the binomial tree. We calculate the stock price in both the states, the up state and the down state, and then we calculate the payoffs in that state. Remember, this was for a call options. That's why we use this formula, max of 0, ST minus K. Expected value after 1 year simply is when we multiply the payoffs with their respective probabilities and add them up together. That gives us the expected payoff after 1 year. So to calculate the value of the option right now at time period 0, we discount it for 1 year at the rate which has been given. So these are the steps. So 15.21 is the current value of the option. Now this was for a call option. What if we had to do the same thing but for a put option? Let's try it out. So we have the same question. Everything is the same. So current stock price is 80, up move, the size of up move is 1.4, risk-free rate is also the same. So the entire question is the same, with the difference that instead of a call option, now we have a put option. Now stop the video for for a minute or so. Think about what is the difference that we need to make in this question now. We still have to make a binomial tree. We need to determine the current value of the option. What part of the entire solution that we did should we actually change? Now, regardless of whether it's a call option or a put option, the U, D, probability of up move, probability of down move, nothing of that is going to change. It's all going to be the same because none of these formulas required us to use call option or put option. These are general formulas. They did not depend upon the call or the put option payoff. So that's one thing that you need to remember, that whether it's call option or put option, it does not matter. U, D, pi U and pi D, all the four are still going to remain the same. We don't have to recalculate them at all, which means that here it's exactly the same thing. In fact, even till the time that you go to the binomial tree where we are calculating the two different stock prices in upstate and downstate, even there is going to be absolutely no change, because remember, till now we have not even talked about the option. We have not referred to the option payoff. We have not talked about call option, put option, nothing. This is just the stock price in the upstate and the downstate. So there's no reason why it should change. Now, where is the change actually going to start from? Once you've calculated the stock prices, we will need to calculate the payoff of the option. That is where the difference is going to start, because the payoff of the put option is not 0 ST minus K, what we had for the call option, but 0 K minus ST. So your formula changes here. So this is the point at which our solution is going to be different now. Now what we do is 80. Now this is your time period 0. What are the option payoffs after 1 year? Now instead of calculating the call payoff, we are calculating the put payoff. So keep that in mind. So we are doing max of 0, 80 minus 112. Similarly, max of 0, 80 minus 56.8. So here, the formula has been reversed. So keep that in mind. So this is the point where you're making the change. Now 80 minus 112, that is of course a negative figure. That means that we're not going to exercise the put option. In the downstate, however, this is a positive figure. So that's the reason why we are going to use the put option, and the payoff is 23.2. Because in this case, you're able to sell the stock for 80. So that's why you're going to exercise. Why would you sell it at 56.8 when you have an option to sell it at 80? So 23.2 becomes your payoff. The remaining steps remain the same. Of course, the values are going to be different. So these are the payoffs that you're getting. The next thing to do is to consolidate the payoffs into an expected payoff after 1 year. So we multiply 0 with the probability of an up move plus 23.2 into probability of the down move. So the expected value after 1 year is 0 into 0.5041 plus 23.2 into 0.4958. If you recall, in call option, the value above was, that's where we were calculating, that's where we were exercising the call option. But in the down state, it was 0. Here, it's the reverse. So 0 into 0.504 plus 23.2 into 0.495, that gives us 11.5. Again, just to remind you, 11.5 is not the current value of the option. This is the expected value after 1 year. So what do we need to do now? This value needs to be discounted to time period 0. So this will be discounted at the rate of 6% for 1 year. So 11.5 divided by 1.06 is 10.85. Now, the couple of points that I mentioned that you have to be very careful about, these are very common traps that are used by both CFA and FRM exam setters. So in almost all the questions, you would notice that one of the options that would be given to you, if this kind of question were to be asked, one of the answer choices would be 11.5, because this is a very common error. So people under exam conditions forget about discounting it. They calculate 11.5 and they immediately see that it's one of the answer choices and they go ahead and mark it. So you would have done all of this and your answer would still be wrong. So make sure you don't make that error. Make sure you remember that this is after 1 year. So you need to discount it for 1 year to get the actual value of the option right now. So that's how the binomial method works for call and put options.